Today we study the Calculus 1. The topic is higher order derivatives. Now look at the question. The acceleration of variable speed linear motion. We can write the distance function s equals st, and then the corresponding instantaneous velocity vt equals s prime t, and then how to get the acceleration. Now, if a is the rate and corresponding the change rate of vt to t, so at equals the v prime t. V is our the velocity function, prime t means our acceleration, equals v equals s prime. S prime 1 time prime means s double prime t. So we can get the acceleration at equals s double prime t. This means the physical meaning of the second derivative. So now look at f prime double prime x equals f prime x and then another time prime bracket prime. How to get it? The definition: limit delta x tend to 0, fx plus delta x minus fx is our function increment over delta x is our ratio, get the limit, and then 1 time prime. So in the definition, the function f is defined as f prime with a first time prime and then limit. This means together 2 times prime means double prime. This means the second derivative. It is rated as the following formulas: f double prime bracket x. This means every time derivative for the variable x. Sometimes we write the function is y, so write it as y double prime. Of course, we can write it. Prime means differentiable for dx, so we can write it d square y over dx square. Try to understand the different two. Sometimes we can write it d square fx over dx square. It is our definition for the second derivative. How to get the other higher order derivatives? Now look at the following tables. The third derivative. How to write it? Yes, the 3 times prime means triple prime. Y prime d cube y over dx cube. Similarly, we can get the fourth derivative. At this time, the number of prime is 4. Because 1, 2, 3, 3 times, 4 times, we write it bracket 4. This means 4 times derivative. Together, we can get the nth derivative. What means is, yes, n times derivatives. F bracket n x, y bracket n, d n power y over dx n power. And then we can write the d n power fx over dx n power. So corresponding, the nth derivative is called the higher order derivative. Higher means corresponding the number n is less than or equal to 2. Corresponding, we can select fx is called higher order derivatives. Higher order means the function itself means the original function. So n equals 0. And then f prime x. This means the third, the fourth, the nth, okay? F prime x is called the first order, means the first derivative. Bracket n is our special number equals 1. Try to understand the definition, the nth derivative. How to get it? Yes, do the n times derivative. F bracket n times. How to understand the dn power y. Pay attention to the first n means n times differential. This n, dxn power n means every time for the variable x. How many? Yes, n times. So dxn power. So now, according to the basic definition, we can do the following examples. Look at the example 1. If y equals sine double x, we know y prime. Now look at the question. The question means try to find the cube y over dx cube, the full power y over dx full power, and then the 12y over dx 12. How to get it? Yes, the definition tells us 3 times derivative, 4 times, and 12 times derivative. So now look at first, dy over dx. The first derivative, sine u equals cosine u times u prime. So equals cosine double x times double. This is the first derivative. Look at second. From here, 1 time, again derivative. So the left equals d square y over dx square equals cosine u. Do you remember? Oh, think it. Cosine u equals minus sine u 1 time u prime means 2. Together, 2 square sine double x. Okay? The third derivative, 1 time again, we can get d cube y over dx cube equals sine u equals cosine u u prime, another constant n, together minus 2 cube times cosine double x. And then we can get the full power y over dx full power y. How to do from here? Cosine u equals minus sine u, minus together positive. Another u prime, we can get another 2. So 2 full power times sine double x. And then we can get the fifth derivative, and then we can get 12th. So final result, d12 y over dx 12 equals constant. How many times? 1 time we can take out u prime. How many times? 12 times. So together, 2 12 power times sine double x. So it is the final result. Try to understand the question step by step. We can get the nth derivative. Now look at example 2. If y equals arc tangent x, try to find y double prime if x equals 0, and y third derivative x equals 0. How to do? The first, we try to get the formula for the double prime, triple prime, and then get the concrete values at the given point. So now look at y prime. According to our basic formula, y prime equals 1 over 1 plus x squared. And then y prime get y double prime. From this basic expression, we can get 1 prime again means double prime. Bracket prime, according to the formula, equals minus u squared times u prime. This is our y prime. And then we can get y triple prime. We can get this. Do this according to u over v, the basic formula, u prime v minus u v prime over v squared. We can get this result. Our answer means get the concrete values at the given point and then taking x equals 0. If in this expression x equals 0, as t equals 0, this 1 plus 0 square bracket square means 0 over some number. The final result equals 0. And then look at y triple derivative. we can get this. Giving x equals 0, final result equals -2. So this question gives another idea how to get concrete values between the higher derivatives. Now look at example 3. If y equals ex power, try to find nth derivative of y. Nth means the first time, first derivative, second, third, until nth derivative. How to get it? Step by step. Now look at the question. Y prime. Y prime equals itself ex. The function is special, y. The derivative function equals itself, doesn't change. So, until y double prime equals itself again. Similarly, we can get y third derivative equals ex. And then we can get first, second, third. Similarly meaning we can include that. Finally, ex bracket nth power means y nth derivative equals ex equals itself. So now look at example 4. If y equals ln 1 plus x, x larger than -1, try to find nth derivative of y. How to get it? Yes, the first derivative, second, until nth derivative. So we can get 1 prime. Y prime equals ln 1 plus x equals 1 over u times u prime. U prime equals 1. So the answer is 1 over 1 plus x, and then y double prime. From this, we can get the derivative again. With small, we can get this result. And then y 3 times prime, we can get this result. And then 1/4 the corresponding derivative until first, second, third, fourth. Together, we can get y nth derivative. Together, we can conclude that according to some of the regulation, we can get corresponding the constant. First prime positive, second minus, third positive, fourth minus. So corresponding constant means the sign is -1 bracket n-1 power. Corresponding this term 4, 4, 3, 3, 2, 2, 1, 1 power. So corresponding nth derivative, corresponding the power is n. This term means n-1. So this term means n-1 bracket factor, where n is larger than or equal to 1, and we defined as 0 factor equals 1. Try to understand the question. Now look at example 5. If y equals sin x, try to find the nth derivative of y. How to get it? Yes, first, second, until we can get some summary. Now look at this. Y prime equals cosine x equals sin bracket x plus half pi. And then get y double prime. From here, it is our sin u. Sin u prime equals cosine u times u prime. U prime equals 1. And then we can write it sin original angle plus half pi. So this together means sin x doesn't change. The two numbers equals double times half pi, means 2 times half pi. And then we can get the triple prime equals sin u cosine u together change into sin x plus 3 times half pi. So now we can get some conclusion. Look at the first corresponding sin x plus 1 times half pi. Second corresponding x plus 2 times half pi. Third means 3 times. 3 times half pi. 1 corresponding 1, 2 corresponding 2, 3 corresponding 3. So together we can get corresponding summary. Y bracket n's derivative equals sine bracket x plus n times half pi. So it's our final result. So we can get this final result. Sine x n's derivative equals expression. Similar meaning, we can get cosine x bracket n's derivative equals cosine x plus n times half pi. Try to remember the two formulas. It is useful in the future study. So now look at our summary about higher order derivatives. The nth order derivatives of some special formulas. You can get it step by step. Look at first. Ax bracket nth power equals ax times a constant. Constant means allowing a n power. Bracket a is a positive number. Special case. If a equals e, at this time equals ex times log e n power. Log e equals number 1. So together it is our special case. Now look at case 2. Sin kx bracket n's derivative. K can be looked at some constant taken out. How many derivatives means how many k's. So k is taken out. Kn power 10 sin bracket kx plus n times half pi. Corresponding cosine kx bracket n's derivative equals how many times the derivative means how many k's. So k is taken out. N power 10 cosine bracket kx plus how many? Yes, n times half pi. Look at this. X alpha power bracket n's derivative. How many times? Yes, n times equals every time we can take out one constant. So alpha times alpha minus 1 until alpha minus n plus 1. X, the power means alpha minus n. Look at 5. Log x. Log x bracket n's derivative equals. Pay attention to the sign, okay? Minus 1 bracket n minus 1. N minus 1 bracket factor over xn power. It is our special case. In the future study, if you can remember this formula, it's very good. If you don't remember, try to get it step by step by yourself. So now, according to our formula, we try to do the following questions. Look at question 1. If y equals x alpha, alpha belongs to the real numbers, means alpha is a constant, means any real number. Try to find y n's derivative. Do you remember something from the above formulas? Now look at this. Y prime means the first derivative equals alpha means any real number. So equals alpha times x alpha minus 1. This is the first derivative. How to get second? Yes, 1 time again derivative to the two sets. 1 first, 1 second. How to get it? Derivative again about the two sets. The left become 1 double prime. The right copy this term bracket prime again. Alpha is a constant. We can take it out. Alpha. Alpha minus 1, another constant. Take it out. So alpha minus 1 times x alpha minus 1 minus 1. Together, alpha minus 2. Similar meaning, we can get the third derivative. Add to this expression, do the derivation when again to the two sets. When third prime equals constant taking out, this term prime again equals alpha minus 2x, alpha minus 2 minus 1, together alpha minus 3. Together, the first corresponding this form. Second, how many? 1, 2, 2 constant. Third, how many? 3. The first, we can look at alpha minus 0, alpha minus 1, alpha minus 2. The power is alpha minus 3. We can conclude that. The third become nth derivative, alpha minus 0, alpha minus 1, alpha minus 2, until alpha minus n plus 1, corresponding this. The power is alpha minus n, where n is larger than or equal to 1. If alpha is a natural number n, and this time we can get y bracket n special case. This means alpha equals n together. Look at this. If alpha equals n, n minus n, 0 power. X 0 power equals number 1. The first, n minus 1, n minus 2. The last term, n minus n plus 1 means 1 times 2 times 3 until time n. This means n factor. So together, y bracket n corresponding nth derivative is n factor. Special case, y bracket n plus 1's derivative means based this formula, we can one time again derivative. N factor is a constant. Any constant c prime equals 0. So n factor prime equals 0. Of course, y n plus 2, n plus 4's derivative is 0, because means any constant prime, so equals 0. Now look at this question. This question means y equals 1 over x squared minus 3x plus 2. Try to find the nth derivative of y. How to get it? If you do this, the first, second derivative, third, until nth, it is not easy for us to try to find the regulation. How to do? We can write it in this form. Y equals 1 over x squared minus 3x plus 2. Write it in this form. 1 over x minus 2 minus 1 over x minus 1. At this time, it's very easy for us. It's a special case, 1 over u. So now we can do y prime from here. Y over u equals minus u squared 1 u prime. Together, get this formula. We can do something about this expression, not this. It is complex, but it's easy for the blue formulas. So again, derivative for this. How to do? We can write it some special case. Minus 1, 1 over x minus 2 square, minus 1, 1 over x minus 1 bracket square. Why write it in this form? It is very easy for us to get some conclusion. So now, y double prime from this. Copy minus 1. This means x minus 2, the power is minus 2, together equals this term. Similarly, for the second term. So now we get it is our double prime, and then we can get our conclusion. Y nth derivative equals, look at, count the numbers of minus 1. Double prime minus 2. So nth derivative n power minus 1 bracket n power. The left constant. Double left 1, 2. Nth derivative left 1, 2, 3, 4 until n. The corresponding n factor. It is our list term. x minus 1 cube, x minus 2 cube. The second derivative corresponding n plus 1. So n means n plus 1 power, n plus power. It's our final result. First, second, we can get the n's corresponding this result. We can take out some common factor. What is our common factor? Minus 1 n power times n factor. This term taken out. So equals the final expression. Now look at this question. If y equals sin x full power plus cosine x full power, try to find the nth derivative of y. How to get it? If we do something from the y itself, it is difficult. We try to do something about y. What we do? According to this basic formula, do you remember cosine x bracket n is derivative? We know how to do. So now try to make y into some special case cosine u. Using the idea, this means if the derivation is very complex, it isn't easy to find out the rules. Try to change the formula into some another formula. So now look at this question. Y equals, it is our original formula. Change into this form. According to sin x squared plus cosine x squared bracket square minus double sin x squared cosine x squared. The first term equals number 1. So we can write it 1 minus this term using the double angle formulas. We can write it this. Still another sin u squared. Using the double angle formula, again, we can get some special cosine u. So we can write it in this form. Equals 1 minus half sin double x squared equals 1 minus cosine 4x means double angle over 2. At this time together, we can get some constant 3 over 4. It's very easy. Why? C prime equals 0. Of course, n's derivative equals 0. 1 over 4 cosine 4x, it is 2. 1 over 4, it is constant. It is located at the k. Cosine 4x means cosine kx. So we can get y corresponding to nth derivative. The first term equals 0. 1 over 4, it is our k taken out. Cosine kx, how many times derivative means how many 4. So this means n power of 4 cosine 4x plus n times half pi. It is our final expression. Now look at this question. If y equals x plus 1 times double x plus 3 square times 3x plus 4 cube, try to find the sixth derivative of y. How about our y? Yes, y is some polynomials. How to do? The idea means this function is 6 degree. Pay attention to the key word. 6 degree polynomials and try to find the 6th order derivative. How to get it? Yes, we can get some 5 degree polynomial, some special terms. So our original y equals, this is our original expression. Write it in this form. It is our 6th degree term. X times double x square 3x cube plus the 5 degree polynomials. And then we can get corresponding 108 x 6th power plus 5 degree polynomials corresponding 6 derivatives equals 0. So together, y 6th derivative, this term equals 108 times 6 factor plus what? Yes, plus 0. So together equals this number. It is our final result. Try to understand the basic formula. Class is over. See you next time.